in a different way the construction of urban infrastructure. Okay, please keep quiet, guys. Guys, keep quiet. Alex, please keep quiet. Okay. However, what would be the side effect? Well, there is urban development, right? Urban development triggers or attracts people to the areas. That may also affect economic activity, right? And at the end, what? More traffic congestion. Okay. So I asked you to carry out service for people, right? So what would be the service about? Pay attention, especially those who didn't attend the last session, the extra sessions. Please check the following. What you are going to do is asking people about their relations between the variables. Let's say, for instance, the relation between traffic congestion and roads construction, right? So you would be asking people, in their view, how is that traffic congestion is affecting roads construction, right? So traffic congestion affecting roads construction, right? And I ask you to develop a relative scale for asking people, right? So people should be responding, answering in that scale. Let's say you end up serving 30 people. And out of that, I don't know, the average number is 6. That's a result. Okay? I've been telling you that means how those variables are related. Let's say traffic congestion and roads construction. See, we don't have time here. We have the 2 variables. So what we are saying here is that those 2 variables relate something like that. Something like that. I'm making an approximation in linear terms. But why that way? First, because this is what? Positive. That means if this one increases, this one also increases. Right? Why here? With this angle. Why that? Why that is low? Why this is low? Why? What is the answer?
It's the 6 that people gave.
Because of the 6. Why? If we say it's 5, that means it's moderate, right? So that means, yes, that affects the other variable, but let's say 45 degrees here is equivalent to 5. If we say 10, that means this one should be extremely what? Steep. Why? Because if we increase this one in a small amount, the increase in the road construction is high. On the contrary, if the slope is low, let's say if we get here 1, or even 0. What would happen if we achieve 0 here? Horizontal. So it's not going to affect the other one. Right? So let me put it this way, and pay attention everybody. What I'm precisely trying you to do is that you get an approximation of how variables relate to each other. Right? So at the end, you are going to get graphics for each of what? For each of the relations. Can you see it? Right? So we are going to get graphics see this one. This one is with a negative slope. Why? Negative sign. Can you see? Okay, pay attention to the following. This is crucial. Everybody, Itzel, Gabi, everybody please. I have mentioned graphics for the relations. Let's see now graphics for what? For the variables. Those are different. Those ones are in relation to what? Time. Okay? We have graphics for the relations, we have graphics for the variables. The graphics for the relations represent causality. The graphics for the variables represent behavior over time. Okay? So some of you are telling me, for instance, that when doing some research in your project, you discovered, for instance, that gas emissions have increased over time. Ah, okay, in that case, well, it's not here that variable, but it could be here, right? Gas emissions here. So you see that that one is increasing exponentially over time. Okay? So in your view, what would be, in that case, the dominating loop? The balancing or the reinforcing? If this one is, if this variable, gas emissions, or the traffic congestion. If traffic congestion is increasing exponentially over time, which loop is dominating? This one or this one? The reinforcing. And that's why the behavior of the fixes are failed. So you are implementing an action, but nothing is happening. Well, yes, something is happening, increasing the problem. Can you see? So I'm going to mention your case, Alonso. Is that okay? Okay. For instance, what we are to do in the model is tracking back. Listen carefully, everybody. We are tracking back the source of the behaviors. What is the meaning of tracking back the source of the behaviors? If this one is increasing exponentially, right? And all the variables are behaving like this. No, wait. What is the source of the problem? Okay. I'm going to erase the graphics here for the relations. Okay? Just to avoid confusion. Okay. What is creating the exponential growth in traffic congestion? Which variable is creating that behavior? And that's when Alonso enters. I was asking Alonso, okay, you have green eyes. Okay? So let's track back the source of your green eyes. Who is creating that in your genes? Then he said, well, one of my grandmothers, right? So here is like doing that. Okay? So if we are creating here exponential growth, we need to come back here, get back and observe where is that same pattern happening. Something similar. What is that happening? Here. This is the key variable. Do you remember this idea of the leverage points? This is the leverage point. Right? This is the leverage point. This is the variable creating or triggering the behaviors. So where should countermeasures should be implemented? In relation to what? To urban development. So that would be in terms of balancing the construction, for instance, of what? That could be one possibility, right? Can you see? Okay. Any other possibility? Any other countermeasure to implement? Can you see? So, going back. So, as you collect data, you obtain numbers. So you collect data from the variables. You collect data from people. You will discover behaviors, dominating loops, and dominating variables. And as you discover that, then you propose countermeasures. Right? What would be next? Let's say we have an additional course for system dynamics, where the next step would be developing the functions, the equations for each of the relations. But that is something that takes ages. It takes a lot of time. It takes a lot of effort and data to collect and to obtain the equations. For instance, with multiple correlations and things like that. Right? So for now, we are just doing a proxy. And what is that proxy? Well, we are just sensing, we are asking people what is the reasoning, the opinions, the views on how variables relate. And then we discover how strong variables relate to each other. How strong. Right? If one variable is very strong, but if the relation here is very small, what would happen? Or it's very weak, let me say. Let's say this is very strong, but this one is like this. What would happen? Would that be the cause of the... No, this is increasing very strongly, but the effect is what? There is no effect. But a very tiny small effect. Then this shouldn't be the cause. We will be looking for other things. Right? So that's what you want to do with your... Okay? Question?